What's up, team? Today we're going to continue talking about parallel lines. Yesterday, or lesson 10, we talked about you were given parallel lines and then we could figure out some angle relationships. Today we're going to go the other direction. You're going to be given two lines, you're not told they're parallel, and because of some angle relationships, we're going to be able to determine that they are indeed parallel. So here's something we talked about last time, but I put it in the form of a conditional statement. It says, if a transversal intersects a pair of parallel lines, then corresponding angles are congruent. We know that that's true because all corresponding angles when a transversal intersects a parallel line is indeed congruent. As a quick reminder, remember that corresponding angles would be angles such as 1 and 2 in this case. They are both on the same side of the transversal and they have the same relationship with their respective parallel line. We know that they're congruent even though we don't know their angle measures yet. Alright, and here are the four other angle relationships that we discussed. So they all fit in the same conditional statement. The underlined portions I have here, I just wrote them all like this because it was easier to do than writing out the conditional statement each time. But you can read it as, if a transversal intersects a pair of parallel lines, then same side interior angles are supplementary. In the same way, then same side exterior angles are supplementary. Then alternate interior angles are congruent. Then alternate exterior angles are congruent. All of those conditional statements are true if the hypothesis here is true, and the key word here being parallel lines. If you are given parallel lines, then you know all these things are true. What if you don't know that you have parallel lines? So in our figure here, we would just erase these little arrows, and now all of a sudden we have these two lines. We'll call them A and B. We don't know if they're parallel or not. We have to figure that business out. Well, if you were given this situation, you don't know that they're parallel lines, your goal is to show that they are parallel lines. What if you are given the fact that the measure of angle 1 is, let's say, 105 degrees, and you're given that the measure of angle 2 is 105 degrees. We'll say that these are given to you. And your task would be to show that these are indeed parallel lines. Well, you could absolutely do that. We know that angle 1 and 2 are corresponding angles. We established that a few minutes ago, and if we know that angle 1 is 105 degrees, we know that angle 2 is 105 degrees, we can then determine that these are indeed parallel lines. Okay, let's recall talking about conditional statements, converses, etc. So a conditional statement is if P then Q. The converse is if Q then P. So let's examine the converse of this initial statement that I wrote up here in black. The converse is if corresponding angles are congruent when a transversal intersects a pair of lines, then the lines are parallel. This converse, I'm telling you right now, is indeed true. Same is true of all of the other four converses. So you can say, if same side interior angles are supplementary when a transversal cuts through two lines or intersects two lines, then those two lines are parallel. Same thing here. If same side exterior angles are supplementary when a transversal intersects a pair of lines, then those lines are parallel. So you'll see it's kind of, it is if Q then P, it is the converse, although it feels a little awkward because we're using some of the same language in the hypothesis for both of these statements. But notice that the meaning itself doesn't change. The key components to this, the hypothesis here, the key component is that the lines are parallel that are given to you, and then their corresponding angles are congruent. Here, the key component of the hypothesis is that corresponding angles are congruent, and the key component of the conclusion here is that the lines are parallel. So you see that the P and Q, the main idea here, has indeed flipped. Okay, let's write up a real quick formal proof here. So here we're given that the measure of angle 1, 105 degrees, measure of angle 2 is also 105 degrees. Here's our figure, lines A, line B, line C. We don't know that A and B are parallel to one another. That's our goal. We're trying to prove that A and B are parallel to one another. Remember, the symbol here means parallel. Line C is a transversal, but we don't really know the angle measures, or we don't know anything about line C other than it forms these two angles here. 1 and 2 are both 105 degrees. So I think this statement this proof here we can wrap up in just 3 steps. So what I would say here first, I would say that the measure of angle 1 is 105 degrees, and then I'd say the measure of angle 2 is also 105 degrees. Sometimes you can link up given statements like this when they are so closely related. They really work together here. When you're given other given statements that aren't necessarily the same type of statement, I would put them in two different lines, but these two are going to culminate in the same idea here. Okay, so our next step here, what I would say is that the measure of angle 1 equals that of the measure of angle 2, and we know that because of the transitive property. Remember the transitive property, let me write this down, transitive property. Transitive property says if A equals B and B equals C, then A must also equal C. So that's what's going on here. We have angle 1 is 105. 105 is the same as angle 2. Well, then angle 1 must have the same angle measure as angle 2. And as I'm writing this out now, I'm recognizing I need a fourth step. I need a fourth step here, and that's okay. So this one's actually going to take 4 steps. Because we need to kind of go backwards here. We know that they have the same angle measure, so we need to say that angle 1 is congruent to angle 2. And this is the definition of congruent angles. I'm noticing in the videos that you all are tuning in, too many people are saying is similar to or is approximately or something like that with this symbol. This symbol means congruent to. It means they are exact. It means they are identical. It's very important that we understand what these symbols mean. Okay, now our very last step, we can absolutely say that line A and line B are parallel to one another. So line A is parallel to line B, and how do we know? We are going to state the converse of the corresponding angles postulate. Now, we haven't named it as such. If you just wrote corresponding angles, I'm okay with that. Technically, we should write the converse of the corresponding angles postulate. So I'm going to write it the correct way here. So converse of corresponding angles postulate. There it is. Now, when we're proving it the other way, if you're given the parallel lines and trying to indicate that, and trying to solve for some angles and whatnot, you should use language such as corresponding angles postulate, same side exterior angles postulate, alternate exterior angles postulate. That language is good and true, although I'm not probably going to be super picky about it, but do be aware that that is the correct grammar, the correct vocabulary. Okay, so we can prove that lines are parallel if we know some of their angle measures. I just did it with corresponding angles. You can do the same idea with same side interior, same side exterior, alternate exterior. It all works the same way. You're going to have proofs on this assignment. So heads up. All right, you got this. Let me know if you have any questions.